So here are some additional notes that you can look at for section 5.2. For section 5.1, I did not have any additional notes. I just want you to look at the guided workbook notes for that section. I felt like there were a lot of examples there that you could look at. So here we're talking about slope, and slope means a couple of different things. The steepness of a line, how steep it is, the rate associated with the proportional relationship, in other words, what's the change, the constant of proportionality, or one of the more popular ones is the rate of change, represented as a ratio of the change in y to the change in x. So we have a formula here. The slope can be found by doing y2 minus y1 over x2 minus x1. You also might see it written as delta y over delta x. Delta means change in y over change in x, or rise over run. So when you're looking at an ordered pair, there's your x and there's your y value. And if I have another ordered pair, we usually just call that x2 and y2, x1 and y1. And that's where the x1 and the y1 and the y2 comes from. So our first example, a chemical spill into a pond. On the first day, day 0, the concentration of the chemical is 100 parts per million. On day 10, the concentration is 92 parts per million. Assume that the concentration is a function of days. What's the slope of the function? So this would be x1, y1, x2, y2. So we're going to do our calculations. Y2 minus y1, x2 minus x1 gives you negative 8 over positive 10, and that can reduce to negative 4 over 5. So what that means is that every 5 days, the concentration decreases by 4 parts per million. Another example, the following point shows the relationship between the speed of sound in water and the temperature of the water. Find the slope and explain what the slope means in the relationship. So 20 degrees and the speed is 1482. At 28 degrees, the speed is 1505. So that means that as the water gets warmer, then the sound increases, okay? The speed increases. So 1505 minus 1482, 28 minus 20 gives me 23 over 8. So that says for every 8 degrees increase, the speed of sound will increase by 23. Okay? Alright, this section also talks about the y-intercept, and the y-intercept is where the line crosses the y-axis, or where the x value is 0. So it can be thought of as the starting point of the graph, or the value where x is 0, or the initial value. So this gets a little bit tricky sometimes, and we'll look at that in the section 5.3. So in example 1, the y-intercept is the starting value. So what was the starting value in example 1? In example 1, on the first day, the concentration is 100 parts per million. So the starting value or the starting concentration is 100 parts per million. Okay, if you're paying for a phone, you have to pay a set amount of $30 for each month. Plus, you have to pay $10 extra for each other line. What's the y-intercept and the slope? So the y-intercept is the starting value. The starting value is the $30. So that's how much you have to pay no matter what that first month, or that for every month. So it could be written as an ordered pair, 0, 30, depending on the problem, or it could be asking you just what is the y-intercept. The slope is the rate of change, and that's how much it changes every month. So that's going to depend on how many extra lines you have. So in this example, the change is $10 per line. So that's what we call our slope. So the slope would be $10. So if I were to write it in terms of an equation, y equals mx plus b, m is my slope and b is my y-intercept. So then I can fill this in, y equals 10x plus 30, and this is an equation that you can write that would be used to calculate the cost of your phone bill.